Okay, here we go. 11.4. So what we're going to be talking about is probabilities, like we've been doing our experiment. So the first blank is probabilities. And probabilities of events are expressed as numbers ranging from 0 to 1 or 0 to 100%. Hey Zeus, will you hit that second light closest to the trash can? Thank you. Alright, so the closer the probability is to 1 or 100%, the more likely that it is that it will occur. So for example, if there's 100% chance of rain, it's probably going to rain that day, right? Did y'all know that percentage of rain is not talking about how likely it'll rain, just it talks about the area it's going to rain in? Did y'all know that? We'll get into that later. So like 100% chance of rain doesn't mean it's going to definitely rain that day. It's just 100% chance of rain in the certain area that it's talking about. But anyways, we'll go over that later. Okay, the closer probability is to 0, like a 10% or 20% chance of rain, the less likely it is that it will occur. Any occurrence for which the outcome is unknown is called an experiment, kind of like us flipping the coin. We didn't know if it was going to land on heads or tails. That's called an experiment. So again, example, tossing a coin, because we don't know what we're going to have. Okay, the set of all possible outcomes in an experiment is called the sample space. So the sample space for tossing a coin would be what? What are we going to get when we toss a coin? Heads or tails. Good, that's the sample space. Heads or tails. Alright, and an event is the subset of a sample space. So if you called tails for a coin toss, your event that the coin would land on tails would be your event. It's the possibility of success. And it's denoted E. So anytime you see E, that means event. And now we're going to use theoretical probability to find out what the probability is of a coin landing tails up. So the formula is NE over NS. Number of possible outcomes in event E, that's your successes, over total number of possible outcomes. That's NS right here. So for the first one, compute the probability of a coin landing tails up. We've already did this, so this is review. How many successes would you have for tails up? How many chances of success? 1, right? 1 chance of the coin landing tails up and flip it once, right? You have 1 chance of getting tails. Chance of success, you only have 1 chance of being successful. And then how many possible outcomes are there if you flip a coin? 2, heads or tails, good. So for the formula, it's just going to be 1 over 2. And if we put that as a percentage, it's what?
0.5.
Times 100? 50% chance, good. That you would get tails from flipping a coin. And I think we talked about that, right? Okay. Any questions about that? Cool. So let's do the probability of rolling a 3, an even number, and a number less than 5 with one die. And anytime y'all do probability, I want you to put it as a percentage and a fraction. And the percentage, I want you to round to the nearest tenth if you have to. Alright, so for a 3, how many times could you roll a 3 for a dice? How many chances of success? 1. Out of how many different numbers on a dice? Good. Go ahead and change it to a percentage. And somebody let me know the percentage. Rounded to the nearest tenth. Anybody? To the nearest tenth. Not percent. Do 1 divided by 6 in your calculator times 100.
16.6.
Good. 16.7. Good. 16.7% chance that you would roll a 3. Yeah. Alright, what about an even number? How many even numbers are there on a die?
3.
Good, there's 2, 4, and 6, right? So that's 3 out of what?
6.
So that's, let's go ahead and simplify that to what? 1/2, good, and that's 50%. Very good. Any questions about that? All right, what about a number less than 5? How many are there? 4, right? 1, 2, 3, 4. Out of how many?
6.
Go ahead and tell me what that fraction would be in simplest terms.
66.67.
Yeah, 2/3. That's what I'm looking for is the simplest fraction. Now tell me the percentage.
66.67.
Good, let's round that to 66.7. Alright, you're doing D and E on your own on the next page. Same thing, just one die.
Wait, we still on the die?
Just one die.
Wait, what is a die? Is it just another dice?
Just one die.
I know because we said 10. And I was thinking, how can we? Yeah, so they just why is the 9 in front of that 6?
But it was Slim Jim. Where'd you get the? Okay. All right. Think about it, guys. How many numbers are there? Okay. How many of those 6 are greater than 10, or less than 10? Excuse me. All of them, right? So it'd be. Go ahead. Oh, numbers. How can you have 9 of those without a 6?
Oh, wait. Number 6? Yeah, number less than 10.
Yes. So how many numbers are on the dice? How many of those are less than 10? 6. You can't have 9 chances of success if there's only 6 of them. But that would be one.
Oh, so
So how many are just like only okay, so it'd be whatever 6.
Alright, let's go over these together. Alright, anybody want to help me with part D? Alright, Alandria, what'd you get?
The answer?
Yeah.
100.
100%, because how many different numbers are there on a die?
6.
How many of those are less than 10?
6.
All 6 of them, right? Remember, you couldn't have 9 because there's not 9 numbers on a dice, right? Your top number will never be greater than your bottom number with probability. Okay? Alright, so this would be 1 if we simplified it. Times 100, that's going to be 100% chance. Alright, anybody want to help me with E? Alright, Paige, what'd you get? Good, because how many numbers will be greater than 6 on a die? None. Out of 6 numbers. So that's 0 times 100 would be 0%. Does that make sense? Sure? Y'all have any questions about those?
No.
Yes.
I don't need my question.
Okay.
Like I have them in my head. Like for the top one,
Mhm.
why wouldn't it be like all of them added up to 21?
Okay.
This is just talking about if you roll a dice one time. So when you roll a dice one time, you have 6 different numbers that you could get, right? Out of those 6 numbers, how many would be less than 10? Only 6 of them, right? Because you're only rolling it one time. Any other questions? Okay, cool. Now let's talk about if we roll 2 dice. So we're going to do A and C together. Okay? A sum of 7. So if you roll 2 dice, how could you get a sum of 7? Give me one of them. It could be 1 and 6, or you could roll a what?
5 and 2.
What else?
4 and 3.
Alright, what else? That's it, right? Okay, so that's 3 chances of rolling a 7. There's 2 dice. We might have to write it out the first time. It's not going to be 12. Anybody else have a guess? Alright, there's 6 chances on the first dice, right, that you roll. There's how many on the second one? 6. That'd be 6 times 2. 36. 6 times 6. Good. And if we want to write them out, I'll write them out quickly over here. So if you roll 2 dice, we could get 1 and a 2, 1 and a 3, 1 and a 4, 1 and 5, 1 and 6, right? And a 1 and a 1, sorry. I could get 2 and 1, 2 and 2, 2 and 3, 2 and 4, 2 and 5, 2 and 6. And I could go all the way to what? 6 and 1, 6 and 2, 6 and 3, 6, 4, 6, 5, 6, 6. And now let's count them up. How many do I have going down? 1, 2, 3, 4, 5, 6, right? How many would I have going across? 2, 3, 4, 5, 6, right? I just skipped some. Sorry. 1, 2, 3, 4, 5, 6. So 6 times 6? 36. So you would have 36 different options if you roll 2 dice. Let's simplify this fraction. You don't have to write all this, by the way. 1 over 12, good. And I'm going to write that over here. And then, so somebody tell me the percentage. Let me see. Yep, 8.3% chance of rolling a 7. And you think about all those people who go gamble and play that number, like 7, I don't know the name of it, I guess it's 7. When they roll the dice and they have to get a 7, they only have an 8.3% chance of getting a 7. And they're betting tons of money on it. That's crazy.
21?
No, not 21. There's a game where you like toss 2 dice and you have to get a 7.
What game that is?
Some money spinning game.
Yeah, I thought it was called 21 because isn't there a movie about it?
There's a game
A movie?
yeah, blackjack.
There you go.
Okay, let's do part C together. So an even sum. So when you roll 2 dice, you'd have to get a 2, 4, 6, 8, right? 10, 12, whatever.
Yeah, so it'd be half. Would be 18.
Would it? Alright, it's out of 36, right? Alright, don't write this part down that I'm writing, but I'm going to list them all out. You could do 1 and what? 1 and 1 would give you 2, right? What would be the next one with 1?
3.
Good, because that gives us 4. 1 and what?
5.
Good. Okay. Anyways, alright, so 1 and 5, that would make 6. Is that all of them with the 1s? Okay, so we could have 2 and what? 2 and 2 and. So it looks like it's going to be 3 for each one, right? So we would go all the way to 6 and 2, 6 and 4, 6 and 6. So how many are right here? 3, right? 1, 2, 3. And over here would be what? So 6 times 3?
18.
It is. Because when you add them together, it's either got to be even or odd, right? So 18 and over 36 can simplify to 1/2, which is how much percent? 50% chance. Now that's something I would rather bet on than rolling a 7. Alright, you're doing B and D on your own. B and D. We just did C. That's okay. Sum of 6. That means we know you guys have to add 6. How many different times can you do that? Okay. That was how you come. It's too difficult to find what numbers add up to get 6. You're not going to count this.
Huh?
What numbers you want? Find numbers that have added up to get 6 from that. That'd be what? 3. Good. That's one of them. That's 2. 1 plus 5. That's 3. Any more? 6 plus 6. So how many are those? 3. Yeah. 3 is how many?
Local 36. So it's the same function number.
Okay. How many different options could you have for two guys?
I guess.
What? There's 6 numbers on the first one, 6 numbers on the second one. So 6 times 6.
Alright, somebody help me with the part B. Alright, Melanie, what'd you get?
I got 8.3.
Good, give me the fraction.
3 over 36.
Good, which simplifies to 112. And what was the percentage?
8.3.
Perfect. Everybody know where this 3 came from?
Yeah.
Okay, let's talk about it then. How many different ways could we add 6 together with 2 dice? You could roll a what?
1 and 5. 2 and 4. 3 and 3 and 3.
Anything else?
No.
And that's 3 different ways out of 36. Good.
Would you not put 6 in 1?
6 plus 1 would give us. Okay. Go ahead, Paige. Oh, yes.
I got, like, for D,
Mm-hmm.
for the end, I got, like, my fraction, I don't know, often not.
Okay. Paige, what'd you get for D?
50%.
Good. What was the fraction?
18 over 36 is what I have.
Perfect. And we could use part C to do this one. If you add 2 numbers together, they're either going to be what? Even or odd. So that's always going to be 50-50. Kind of like heads and tails. It's either got to be heads or got to be tails. Got to be even or got to be odd. Any questions about those two? Okay. Let's talk about number 4 then. So a deck of cards. And this says standard deck, but let's go ahead and talk about what that is. It's 52 cards. Go ahead and put 52 cards in parentheses, no jokers. That's a standard deck. 52 cards with no jokers. Alright, so say all of these, the cards have been shuffled and you're just drawing 1 card. What would the probability of getting a king be? So what are your successes out of the whole deck? How many kings are there? 4. Out of how many?
52.
Good, let's simplify that. What goes into 4 and 52?
2.
Okay, how many times can 2 go into 4?
2.
And 2 go into 52?
26.
Good. Can we simplify this?
Yes.
Alright, what goes into both?
2.
On top?
1.
Out of? Good. So this is what the probability would be, 1 out of 13. And tell me what the percentage would be.
7.7 or 7.7.
Good. So if you drew out of a deck of cards and you're trying to draw a king, you'd have a 7.7 chance.
So there's four, cause I don't know what deck cards, not play cards. So there's four of each
Suit.
number.
Except for jokers, there's like 2 of them, but we're not dealing with jokers. So yeah, each one has 4. Alright, we're going to do C together, then you're going to do B and D on your own. So the King of Hearts. How many kings are there, first of all?
4.
Out of those 4, how many are hearts? 1, right? We have hearts, diamonds, clubs, spades. Y'all don't play, or no, clubs and clovers. Is clubs and clovers the same thing? Okay, so clubs and spades, yeah. That's what I thought. Okay, so the King of Hearts, there's how many in a deck? 1. Out of what? So go ahead and tell me what that percentage is. 1.9% chance of drawing a King of Hearts. It's pretty small.
So what if you don't know?
About cards? We'll go over them together. Huh?
What is a red?
A red.
Yeah, a red card.
Do I need to put a picture of a deck of cards in my room somewhere?
Yeah.
Okay, I will.
A red card is like everything.
Alright, so a heart, we'll go over both of them together then. A heart, how many different,
There's 4.
there's 4 different what?
It'd be 13.
What's it called? 4 different what?
Suits.
Suits. Good. There's 4 different suits, so you would do 52 divided by 4, which is what?
13.
13. So they are 13 out of 52 hearts in a deck. And then how many, what can go into 13 and 52? 13, right? How many times can 13 go into 13?
1.
And into 52? So what's the percentage that you will draw a heart?
25.
25%.
Red card should just be 50.
And then with the red and black cards, they're half and half. You'll have half black cards, half red. So this will be 26 out of 52, or 1/2, which is 50%.
Would it be cool to put 50%? Like right on
You'll need a fraction. I need it as a fraction and percentage. And the reason I do that, I wouldn't be very picky about it, but on the ACT, sometimes they'll ask for probability, and they'll have it as a fraction instead of a percentage. Yes. Oh. Does everybody understand? Okay, then y'all don't know what face cards are then. If you don't. Okay. Under this, go back and write face cards, because they'll ask you some questions about face cards. Those are just Jack, Queen, and King. Cards that have a face on them. So when they say face cards, they're only talking about Jacks, Kings, and Queens.
How much
Something else.
There's 4 of each, yeah. So there's 12 face cards in a deck. No, we're not dealing with jokers. So only Jack, Kings, and Queens, so there's 12 face cards in a deck, because there's 4 of each. Alright, flip. So we've talked about theoretical probability, that's what we've been doing, and it's based on a set of equally likely outcomes and the number of elements in the set. So like flipping a coin, theoretical probability, because it's equally likely chance. Excuse me. Same thing as rolling a dice. So in contrast, empirical probability is dealing with situations in which we look at the frequency of occurrence of an event. And there's a formula for it. And it's just observed number of times E occurs, so how many successes occur over total number of observed occurrences. So all the options in total on the bottom. So Bailey, if you'll read number 1 for me. Just number 1, not part A.
There are approximately 3 million aliens in the United States. 0.69 million be believing in national 1.26 million remain Catholic. 0.36 are Protestant. And 0.69 million are
Okay, so if an Arab American is selected at random, find the empirical probability of selecting a Catholic. So our success would be selecting a Catholic, right? What percentage are Catholic?
36%.
Says 1.26 million are Roman Catholic. So that would be our success, right? Picking a Roman Catholic. and then out of all Arab Americans. So what is the total of Arab Americans? 3 million. So it'd be 1.26 over 3. And this one, since it has a decimal in it, I don't want you to simplify it. I just want you to give me the percentage. So what percent of Arab Americans are Roman Catholic? 42%. Very good. Do B and C on your own. Anybody need more time? All right, Lyric, will you read part B for me?
If an Arab American is selected at random by the empirical probability of selecting the most.
All right, so what is our chances of success, or the number of times E occurs?
12.6.
What'd you get, Lyric?
1.26. I got 3. Yeah, I got
What's going to be our numerator?
0.69.
Good, over 3. And what was the percentage?
23.
Good. 23%. Any questions about that one? All right, Alyssa, read part 3 for me, or part C, excuse me.
If an Arabian American is selected at random, find the empirical probability of selecting the top.
So what is my numerator?
0.36.
Over, and what's the percentage? Good. Any questions about that one? Pretty easy. Cool. All right, last thing we're going to look at is this table. So these are different students, and there's 1,200 students that took this exam. And here's their score. So it goes from 100 to 200, and here's the number of students that scored in between. Okay. So we're going to find the probability that of a student selected has made marks under 140. Okay, so how many boxes are we looking at if it scores under 140? 2 of them, right? How many for this first box?
63.
And 142. See how they're all going to be under 140? So if we add these two together, 142 plus 63, we get what? Okay, that's the number of students that made under that. Out of how many? 1,200. Good. Go ahead, and I won't make you simplify this because it'll take us a while. Go ahead and tell me what that percentage would look like.
17.
17 point what?
Well, there's 0.8. So 17.
Good. 17.1% of the students scored under 140. All right, what about above 180? Just 175?
Well, I thought we would do 320 plus 175.
Well, in this one, they scored what?
160 to 180.
Between 160 and 180. Which one's greater than 180? This section, right? Good. So it'd be 175 over what? Good. 1,200. Tell me the percentage. Everybody agree? 14.6%? Alright, do part 3 on your own. And I'll call on somebody. Alright, anybody want to tell me what they got for their numerator? Good, 995 over what? And so our final percentage would be 83%. Good. 995. Alyssa, go ahead and tell her what we added together. Good. Everything in this column is either got to be 140 or below. So if it's between 140 and 200, you would add up these three columns. Yes. Yeah. The last thing we're going to do is play a review game of this chapter, and it's on Kahoot. So if you will, go ahead and get out your phone. You can work in groups of two, but I prefer you not to. And if you work in groups, you only need groups of two, no more than two.
No, we leave it to the
Yep.
It's two. Wait, we might get it.
Yeah, I'll save the game for tomorrow.
I was about to say,
And your homework is on a deck of cards, but I'll pass that out tomorrow so I can have a deck of cards up on the board for you to look at. No. I have deck of cards. I have like 4 of them. Oh, you got one. You'll need to finish it in here for the apartment, or you can finish it on your own with the apartment. But I'll need it back. Here you go. Okay, Larry.